All right, so we're now moving on to section 7.4. Section 7.4 is going to be broken up into two different videos. The first video is just going to be using the properties of logarithms. All right, and what you need to be able to understand, or what you need to be able to do is to use the properties of logarithms, and you'll see that they have corresponding properties to exponents. All right, so let's go through some of these properties then. So properties of logarithms, you will need to be able to do this in both ways, meaning you will need to be able to get a logarithm given to you and then separate it, like this one is here, because they're being multiplied, but you'll also be able to go, if I have two logarithms with the same base, then we can, and they're being added, then we can multiply the numbers together. So one of the things that you have to be able to identify for this is that they must have the same base. So if they do not have the same base, you cannot do this property. All right, and then since they are being added together, this can be rewritten as log base b of 3 times 2 or log base b of 6. These are interchangeable. They represent the same number, they represent the same thing, but just presented in a different way. All right, so the product property is if we have two logarithms with the same base being added together, then we can multiply them together, the two numbers together. And also, if we're given a log with the base 6, if we wanted to separate this, we could also separate into what we originally started with log base 3 plus log base b of 3 plus log base b of 2. All right, same thing for division. If you have two numbers being divided, then that means that our logarithms were subtracted to begin with. Or if we have two logarithms being subtracted, then we need to divide the numbers. So log base b of 8 minus log base b of 2. So we can then combine these into one logarithm by log base b of 8 divided by 2 or log base b of 4. And once again, you're going to have to be able to go in the reverse order as well, where if you're given this, you might need to rewrite it and separate our logarithms. It all depends on the type of problem that we were given. And then the last one is if you have a logarithm and it's raised to a power, then the property for this is you take that power and it moves out front and it gets multiplied to our logarithm. So if we have log base b of 5 squared, we can take this 2 and multiply it and bring out front, and it becomes 2 log base b of 5. And then you'll also at times need to be able to go in the other direction, where if you see a number being multiplied to our logarithm, it means it's being raised to a power. All right, this one here, you need to be able to do, especially all these you need to be able to do, but this one we will be using to solve for logarithmic equations. You use all these to solve for logarithmic equations, but this one here is the one that I see a lot of people have trouble or struggle with when solving for equations. Now before we move on, it's more important with the second video, but I want to talk about this a little bit in more detail. All right, so if we have, say, log base 2 of 4, one of the things that we can do is we can rewrite this 4 as 2 squared, log base 2 of 2 squared. Now remember, since logarithms and exponential equations are inverse functions or inverse equations, these two, as long as if we have the same base, which we do, the base in our exponential equation is a 2, and then the base in our logarithm is a 2. So since these two have the same base and logarithms and exponentials will undo each other, this will cancel out and just give us an answer 2 because that was our power. So if we have log base 5 of 5 to the 3rd power, these two, the log with the base of 5 and the exponential with the base of 5, will cancel each other out, and then our answer would just be 3. Right? That's needed for the next video, not so much for this one, but it's just another property I want to go through with you guys, just so that you knew it. All right, so let's go ahead and start solving some problems. All right, so we want to simplify these as a single logarithm. All right, we're going to go a little out of order and do b first and then a. All right, but we want to rewrite these as a single logarithm. So the first thing that we need to do, if we want to start combining anything together with this plus sign, we need to take these exponents and we need to rewrite them. So we're going to move these back into their original place. So this will become log base 2 of x to the 6th power plus log base 2 of y to the 5th power. So we took those exponents and we moved them back in their original place. Right? Then what we will do is we see that we have the same base. we know that addition means multiplication. We can then rewrite this as log base 2 of x to the 6th times y to the 5th. Since x and y are numbers that we don't know, there's nothing that we can do with this, and that's the final answer for this particular problem. If they were the same base, so x and y were the same ones, then we could end up multiplying those two powers together and adding our powers. But since they are different bases, there's nothing that we can do at this point. All right, so that's our final answer. For this one, we know that subtraction means division based on the properties, so this can get combined in log base 4 of 32 divided by 2. Because since they have the same base, we can divide these. 32 divided by 2 is 16, so it's log base 4 of 16. Now, this we couldn't do anything more because x and y were variables and we didn't know what the numbers were. However, since this is both numbers, 4 and 16, we need to keep going. And just to practice on what we did on the last part here, where if we have an exponent and a logarithm raised with the same base, that they cancel each other out, we're going to rewrite 16 as 4 squared. So log base 4 of 4 squared. And since they have the same base, so log with an exponent with the base of 4, a logarithm with the base of 4, they will undo each other, and our final answer for this will just simplify to 2. So if you plug this into your calculator, you will get 2 as an answer. So these are interchangeable, right? And that's combining our logarithms into one logarithm. The next problem that we're going to do is we're going to separate them. All right, so this says, what is each logarithm expanded? So that means we need to rewrite them as separate logarithms. So this one here, it has a division, and we know division means subtraction, so we can write log of 4x minus log of y. All right, now we're not done though, because this 4 and this x are being multiplied, so we need to separate those logarithms as well. So it will be log of 4 plus log of x minus log of y. All right, and we know that this is an addition because they're being multiplied, and multiplied and it means that the logarithms were being added together. All right, when there's no base written, remember it's understood that it's 10. So this will be a log with a base of 10, even though it's not written there, that's what its base is. All right, so this is log of 4x divided by y expanded out. And now for this one over here, same thing. It's being divided, so we'll get rid of that one first. So it's log base 9 of x to the 4th power minus log base 9 of 729. And then the next thing that we can do is we can take this power 4 and rewrite it out front. So it'll be 4 log base 9 of x minus log base 9 of 729. Now remember, when we have numbers and no variables with our logarithm, we should see, can we reduce this? And since 729 is equal to 9 cubed, we can. And now I was knowing I was going to try and use 9 because that was my base 9. And I knew if I had 9 raised to a power, that it could simplify even more. So then our next step will be 4 log base 9 of x minus log base 9 of 9 cubed. Since we have an exponent with the same base as our logarithm, then we know that the base 9 for a logarithm will cancel out with the base 9 of the exponential. So it's 4 log base 9 of x minus 3. And that's your final answer. All right, so that is this expanded out. All right, that is it for this video. One more and then we're done this section.